4.1, combining functions graphically. So when I say combining functions, there's different ways that we can combine them. So one of those ways is by adding, another way is subtracting. And what we actually do is we combine our y values. The x values we don't combine, they are still x. We combine the product or the sum or the subtract, the difference, any of those things. So what I want you to do is we're going to just start by making a table of values, and we're going to do let's go -8 on both graphs. We'll go -6 on both graphs, -4, -2, 0, 2, 4, 6, and 8. So I want you to pause the video, and I'm going to have you fill in this chart. Actually, I do this. We need more room. So we're going to do f of x, which is this function right here, and then g of x, and just plot the points. So I'll give you the first one. So we have -8 and 8. And in our g of x, it's -8 and -10. So pause it and fill in this chart. So you should have got I didn't do 6, I just did 4. Well, we can do -6. Okay, so you should have got -6 and 6, -4 and 4, -2 and 2, 0 and 0, 2 and 2, 4 and 4, 6 and 6, and 8 and 8. That's what you should have got for all of those points for f of x. And for g of x, you should have got -6 and -8, -4 and -6, -2 and -4, 0 and -2, 2 and 0, 4 and 2, 6 and 4, and 8 and 6. Okay, so to find f plus g of x, so that's one way of writing it, or you can write it like this. But to find that, what you're going to do is just add together your y values. So we have 8 plus -10, so our combined function would be -8 and -2. 6 and -8 makes -2, so it'd be at -6 and -2. Okay, I want you to pause the video and fill the rest in. Okay, so this is what you should have gotten, and what you should notice is that they all stayed at -2 until we hit that 0 and -2, and then it became positive. So the way that this graph would look is it's a straight line going from here to here, and then it goes to 2 and 2, 4 and 6, 6 and 10, and then we are out of room, so it would look like that. And the reason why this side shelves off at -2 is because as this line gets bigger and this line gets smaller, the difference between them is still always going to be -2. So there's our function of a combined graph. You don't actually have to make a table of values like this, but it helps to keep yourself organized, to know what you're doing. So again, you're combining the y values, not the x values. So for our function f plus g of x, our domain is all the real numbers. You can go on and on for both sides, and our range is going to be greater than or equal to -2. I ran out of room, so I'm just writing that. Okay, it's the same exact graph, but instead of adding them, we're going to subtract them. So if you want to write out the table of values again, you can. We probably don't need all of them. So even if we just did, we're going to do f minus g. Even if we just did, let's do, let's go -8 and 8, and let's go -2 and 2, 0 and 0, 2 and 2, and 8 and 8. We don't need all of them. And then our matching points are -8 and -10, -2 and -4, 0 and -2, 2 and 0, and 8 and 6. Okay, so for this one we are going to subtract our y values. So we have 8 subtract -10, which is 18. So our new point is at -8 and 18. 2 subtract -4 is 6. 0 subtract -2 is 2. 2 subtract 0 is also 2. 8 subtract 6 is also 2. So this one's going to look similar. It's shelving off at 2. And then to the left of it, it's getting bigger. So we go to 2 and 6. And really, we're going to run out of being able to write things here. So it's going to go up like that. So for f minus g of x, our domain is all the real numbers. And our range is going to be greater than or equal to 2. And there you go. Okay, 2 more things we can do is we can multiply or we can divide them. So let's make a table of values here. Again, it's the same graph, so we don't need to do a lot of work. We can do, well, there's no point in going very far here. Let's go -2 and 2, -2, sorry. We can do 0 and 0. We also have 1 and 1, and we have 2 and 2, and we have 4 and 4. That should be enough. So our counterparts are -2 and -4, 0 and 2, -2, 1 and -1, 2 and 0, and 4 and 2. Okay, so we're going to do f times g of x. So we're going to multiply our y values together. So our -2 stays the same, and then we have -4 times -2, which makes +8. 0 stays the same, -2 times 0 is 0. 1 stays the same, -1 times 1 is -1. 2 stays the same, 2 times 0 is 0. 4 times the same, and 4 times 2 is 8. So we're going to go ahead and plot these points. So we have -2 and -8 down here. Then we have 0 and 0. Then we have -1, 1 and -1. And then we have 2 and 0. And then we have 4 and 8. So this turns into a cubic function that looks like this. So there is f times g of x. And for our domain, it's going to be all the real numbers. And our range is also going to be all the real numbers. Okay, for the quotient, this one has a little bit more work that goes with it. Not more work, but more things you have to think about. And it's just because we're dividing, and sometimes we have, I don't know why that 51 is right there. Sometimes when we're dividing, we have non-permissible values. So let's go f of x, g of x, and f over g of x. So let's use the points. Let's use all of the points like we did for the first one. So we have -8 and 8, negative 4 and 4, we'll skip 6. Negative 2 and 2, let's use 1 and 1. Negative 1 and 1, sorry. 0 and 0, 1 and 1, 2 and 2, 4 and 4, and 8 and 8. And now we'll have negative 8, negative 10, negative 4, negative 6, negative 2 and 0, negative 1 and negative 1, 0, and, oh, I got that backwards. It's negative 2, negative 4. Oops. 0 and negative 2. There we go. 1 and 1. 1 and negative 1. Negative 1 is with 3. What am I doing? 1 and negative 1. There we go. 2 and 0. 4 and 2. 8 and 6. Okay, so we're going to divide them. So we have negative 8 and negative 10 over 8. Or we're going to do f of x divided by g of x, so f of x is on the top. So sorry, negative 8 over 10, so 0.8. We have negative 4 and 4 over negative 6, so negative 4 over 6, which is negative 2/3. We have negative 2 and negative 2 over 4, so negative 1/2. Negative 1 and 1 over 3. 0 and 0 over negative 2, so 0. 1 and negative 1 over 1, so negative 1, so that's an invariant point. Okay, here's where we have a problem. We have 2 and 2 over 0, so it's undefined, which means it's going to be an asymptote. You probably thought to yourself, she's not going to have to say asymptote anymore. That is a thought that was wrong. Okay, we have 4 and 4 over 2, so 2 and 8. I really ran out of room. 8 and 8 over 6. So we'll go ahead and we're going to plot these points. So we know we have an asymptote at 2. So that's going to be our first thing I'm just going to throw in there. And then I'm going to do some of these like nicer points. So at negative 2, we have negative 1/2. So that's like right there. And at 0 and 0, it touches. And then at negative 8, it's at negative 0.8. So it's like right here. So this one is going to go like this. And then it's going to go towards the asymptote like that. And on the other side, we have a point at, or we have 1 and negative 1 right there. We have a point at 4 and 2. So we have a point right there. And what do we have? 8 and 8 over 6. So that's a little bit over 1. So this one's going to go like this, towards the asymptote and then out. So there is our graph. So for our domain, for f over g of x, x cannot equal 2 for the real numbers. And for our range, we can just say y is an element of the real numbers. From what it looks like, it's going to hit every point at some point. Alright, and that is how you combine functions graphically. Just combine your y values.